Hello, everyone. Welcome to this track. And, I'm really excited that we have Mina Zarabian, CEO and co-founder of Carbonova. She's joined us from Calgary in Canada. And she's going to tell us about sustainable carbon nanofibers. So recycling greenhouse gases to produce high-value products, in this case, carbon nanofibers. So, Mina, the stage will be yours. You'll have up to 20 minutes to present and then a few minutes for Q&A. If I feel like you're overrunning 2 minutes before the end of your presentation, I'll pop my head back in and give you a reminder, but I'm sure you'll be fine.
All right.
So without any further delay, the stage is yours and yeah, please.
Okay. Hi, everyone. Thank you, Khasha, for the invitation. I was last year an attendee in TechBlick. Got very interested about all the presentation last year, and very happy that I have the opportunity to present this year on our journey in carbon nanofiber production. I'm in Calgary. You see behind me Calgary Tower, and I don't promise you that the weather is going to stay the same until until the end of my presentation. We have very abrupt weather change here. So with that, I'm going to start my presentation on sustainable carbon nanofibers. And hopefully by the end of my presentation, you're going to learn how we are locking carbon emissions in solid carbon. Okay. Over 2,800 companies have detailed planning for net zero emission by 2040. And this number last year when I was presenting the same slide was 1,000 companies, and every day is increasing. You see from many different sectors, from construction, auto manufacturing, plastics and electronics, even services. They're trying to set goals for CO2 emission, net zero emission by 2040. But this is not an easy task. It requires a lot of changes in the energy transition and supply chain. Carbonova offers a unique solution to utilize carbon dioxide and return it into a product that many of these industries can utilize. Let's look deeper into what is our process. We have a catalytic conversion process that starts with greenhouse gases as our feedstock, as our input, which is CO2 and methane, both with high global warming impact. It goes to a chemical catalytic reactor and it's converted into carbon nanofibers, and byproduct is water. Water is condensed in like many other chemical processes and regenerate heat. So that allows that we have very energy efficient process. Many carbon utilization processes developed up to date are very energy intensive, are very endothermic processes. And in many cases, the CO2 emissions from heat requirement of those processes surpass the CO2 utilization that they have. But our process is a slightly exothermic process, and it generates heat, so it requires less heat for the production. And that allows to reach to net zero or even negative emission. We produce carbon nanofibers in the context of business, and even some technical carbon nanofibers and nanotubes are interchangeably being used. Everybody knows that they're a fantastic material, multifunctional, and they have a lot of applications. So I just pass this slide and go to this one, that CO2 utilization divided into two different paths, either non-conversion methodologies like solvent heat transfer fluid, or conversion technologies that is converted into fuels, chemical polymers, or it converts into solid materials. And because a lot of construction industries are urged to reduce their CO2 emission, most of these efforts in solid materials production are focused on building materials. And if we look at the global CO2 utilization market, by 2040, it reached to over $500 billion market. And a big portion is in building materials and polymers, two sectors of applications that we are also focused in. Another important point here is that fuels and chemicals in most cases are going to releasing CO2 during their cycle of use, whereas solid materials, building materials, are nearly permanently sequestering CO2 and locking CO2 for a very long time. It's very difficult to define the quality of